Hello, everyone. I'm happy to be here. Do you guys watch my show, Outrageous Acts of Science? No, then let me show it to you. Here's a little clip.
3, 2, 1, explosion, please! You're witnessing a US military contractor destroying 100 tons of weapons in Iraq. But what our experts are witnessing is the anatomy of supersized carnage.
First thing you see is the light that's formed from the explosion. And the second thing is that you notice the tripod of the camera shakes, and this is because a shockwave from the explosion has travelled through the ground and is now shaking the tripod legs. And then the third thing is that we hear the explosion and we hear the sound.
That's a clear illustration of the difference between the speed of light and the speed of sound.
Very interesting. But what, in the name of science, is that?
Do you see what looks like some sort of a halo effect? And what this is due to is the expanding gases of the explosion rush out rapidly and they displace the normal air around them. And you have a region of low pressure. And surrounding this is all of the compressed air of very high pressure. And then surrounding that, you have your normal air.
So as this area of low pressure air is forced to increase, it gets colder, and cold air makes clouds. So bizarrely, for a fraction of a second, you are looking at a cloud of water vapor.
All right. Uh-oh. I also do some more scary shows, like this one.
The Earth is doomed. A devastating force is coming, and we're running out of time. As civilization crumbles around us and our planet is destroyed, can we build spacecraft to take us to new, habitable worlds? Can humankind escape annihilation? Can we evacuate Earth?
So, let's go with the lights up and let's get rid of this. Alrighty. All right, so I am an astrophysicist. You guys know what that is? I unlock the secrets of the universe. So this is a school of math and science, so I assume that many of you are interested in math and science, right? Yeah, and scientific careers? Yes, well, I encourage you to do so. A lot of people think that math and science is hard. Do you think that? Yeah, some people say, yeah, well, guess what else is hard? Being broke. So, you know, it's two ways to go about life. You can do the work up front and kind of relax on the back end, or you can just work hard all the time and not getting much out of it. And so math and science is a way of having a really good and great life, right, while doing interesting stuff, because my job is basically to follow my curiosity, right? Whatever I think of that I want to explore, that's what I do. And I don't want to spend all my time up here talking, because I know you guys probably have some burning questions about how the universe works. Is that true? Yes? I keep hearing a voice that says no to every question. But I want to tell you a little bit about my background, because when you see people on television and you see scientists speak, you might think to yourself, oh my God, that human is so brilliant. I could never be that guy. So let me tell you a little bit about my background. So you guys are all junior high school and high school students, right? So some of you are in college? 7 is not middle school? Okay, well, let me tell you a little bit about my background to let you know what type of person you need to be in order to become one of the world's top scientists or a science television personality. First off, we all start from our parents, right? So my mother, she dropped out of school when she was in the 10th grade, and she was pregnant with my older sister. My father, he dropped out of school when he was 9 years old, and he couldn't even read until he was in his mid-20s, right? And for my part, I didn't drop out of school, I finished school, But, you know, I grew up in rural Mississippi, and I really didn't know a lot, right? So I went to the military, I went to the Navy right out of high school. And I'll tell you how good my high school was in Mississippi. So in the year 2000, Mississippi evaluated all of its schools, and every school got a ranking from 1 to 5. One end was the best schools in the state, the other end was the worst schools. There were only 4 schools in the state that got the absolute worst score, all right? 2 of them were my junior high school and my high school, all right? So I didn't know much of anything coming out of high school, and so I went to the Navy, and I left the Navy, and I didn't know what to do. I was just hanging out, and I had a couple of friends who, believe it or not, were from Chicago, a guy named Ice and another guy named Chris Mack, right? And they said, hey man, we go to this school, Tougaloo College, right up here near Jackson, Mississippi, and you should come. And I was like, I don't know, man. And they were like, it's 8 to 1 female to male. And I was like, sign me up, right? I'm down. So I went to Tougaloo, and I go to my first week of classes, and I don't know if you guys have ever seen this before, but I had never seen this before. The professor, it was a math class, the professor went up to the board, and he started writing things. And he was talking about what he was writing. And all the students were sitting there with paper, and they were writing things too. And I'm looking around the room, and I'm like, what is going on in here? What is everybody writing? And how do they all know what to write and I don't, right? Have you guys ever heard of taking notes? Yeah, I had never seen that before in my life, right? And what I ended up doing is, I ended up drawing the conclusion that I just wasn't smart enough for college. It's a true story. And I dropped out. I dropped out of college, and I got a job as a janitor at a nearby hotel. The hotel was called the Ramada Renaissance Hotel in Jackson, Mississippi. And I'm there, I'm being a janitor, making $4 an hour, right? And the bellhop got fired. You know what a bellhop is? Yeah, the bellhop's the guy who takes your bags up to the room. Now, the difference between being a janitor and a bellhop is a bellhop got tips. So, you know, you can get $100 a day in tips, right? So I'm thinking I'm gonna apply for the bellhop position. And I applied for the bellhop position. And you know what happened? I didn't get the job. I wasn't bellhop material, right? They were like, you're not quite smart enough to be a bellhop. So they didn't actually say that, I made that up. But I thought to myself, I can't move up from janitor to bellhop. I better go back to college, right? So I did. I went back to college, and as they say, the rest is history, right? But it was a hard road. I'm not gonna go into all the stories about that. You can read articles about me on the internet about that. But you know what? I love the universe, I love science, I love students, and I know that you guys and your questions will be far better than me standing up here and talking to you for a half hour, 40 minutes. So let's have some questions. Who has questions? The lady in the front. Yes, come on, we have a microphone right here. Yeah, you? No? Yeah, yes, no, yeah. What was that? You just wanted me to see you? Hi, he was like, hey. Come on, don't be shy, or else I'm gonna start talking again, and you don't want that. Huh? This is the first, I've been to schools all over the world, and this is the first time. Yes, all right, come up and ask your question. Don't be shy. The people who speak up do the best in life. It's true. Except for the quiet ones who do really good.
Good morning.
Good morning.
I had a question about what, is your theory on the start of the universe?
Okay, so this is one of those interesting topics, the start of the universe, what we call the Big Bang Theory. So a lot of people think that the Big Bang Theory is just like an idea, right? Like, let me give you 3 words: law, theory, and fact. Scientifically, which one of those represents the highest state of knowledge? Fact, that's what everybody has to say. Which one represents the least amount of knowledge? Theory, right? That's what everybody has to say. Guess what? That's exactly wrong, right? In science, when we say theory, what that means is, it doesn't mean a guess. It means a body of mathematics that describes a physical phenomena. So a set of physical phenomena. So the theory is the highest state of knowledge. Let me give you an example. Isaac Newton created the law of gravity. And the law of gravity says if I have 2 bodies that have mass, there's gonna be a force between them called gravity. And that force depends on the amount of mass that's present and the distance between them, right? But does it tell you why that force exists? No, it doesn't. Later, Albert Einstein comes around with his general theory of relativity. And what Albert Einstein says is, Isaac Newton, you're tripping, homie. There is no force. The sun, the earth is not here sending out a message to the sun or the moon telling it what to do and they're attracting each other. That's not what's happening. What's happening is that the earth is curving space-time in its vicinity. And what the moon cares about is what is the shape of space-time right here where I am? And that determines how the moon moves. And so it's forced to follow the shape of space-time. So Einstein's general relativity theory is able to explain things that, and predict things that Isaac Newton's gravity could not. For example, light is affected by gravity. There's a phenomenon known as gravitational lensing, where light its path gets deflected by the presence of gravity. All right, so the Big Bang Theory is one of the most successful scientific theories there's ever been. And here's how that works, right? When you write down a theory, you're able to make predictions of things that nobody ever thought of before. Let me give you an example. In the year 1818, the French Academy was trying to figure out this thing called diffraction. It has to do with light. You ever notice when there's oil on water, it makes this rainbow effect? Yeah? And so nobody could explain why that occurred. And so they had a contest. And this guy named Fresnel submitted an essay. And Fresnel's essay explained this property of light. And he said that light was this set of waves. It traveled as waves. Now, nobody believed that. And so what do scientists, suppose I'm a scientist. What's your name, sir? Yeah, you. What is it? What? A beer? Javier? Javier. Suppose Javier is my fellow scientist. And Javier comes up with this great explanation for something that we don't understand. As his fellow scientist, how do I react to that? Do I say, great job, Javier? Everybody, Javier, Javier. Is that what I do? Is that how I react to Javier's success? No, I hate him, right? Right? I don't want him. I want to be the smartest guy. So when Fresnel came up with these equations that describe diffraction, this other scientist on the panel, Poisson, he's like, I hate you, Fresnel. So he took the equations to see if they predicted anything that we know is not true. And he found that they did. Fresnel's equations predicted that if I took a ball, a circular object like a basketball, and I take it into a dark room, and I shine a light on it to cast a shadow, Fresnel's equations predicted that there would be a spot of light in the center of the shadow, because the waves would bend around the ball and they'd add in such a way that you get a spot of light in the center of the shadow. Now that's clearly ridiculous, right? The shadow would be the darkest in the center. Why would there be a spot of light there? And so this other guy on the panel named Arago, he said, well, I've never done that experiment. Let me take a ball into a dark room and cast a shadow and see what happens. And guess what happened? The spot was there, right? Now, in science, a lot of people think that science proves things. It's great to come up with an explanation for something, but that's not when you're really doing science. When you're really doing science, you write down equations and you make predictions of things nobody has ever seen, and the wilder and crazier, the better. And that's how the Big Bang Theory came about. These scientists in the 1940s came up with this idea for explaining why we have 74% hydrogen, 25% helium in the universe. And if you want to know it in detail, put my name in YouTube and there's a talk on it that I did, right? And so from that, we've made all these crazy predictions. There's about 12 of them now of things that we could go out and observe with high precision to test whether or not the universe really was small, hot, and dense. And guess what? Every prediction turns out to be exactly true, right? So there is no room for guessing how the universe began. Right? We observe how the universe began with very high precision. And the universe was very small, very hot, very dense. And so this Big Bang model of the universe is as much a fact as me observing that you're sitting there in those chairs right now. But the thought process to get there is very complex, right? So people don't take the time to understand. Great question. Yes, ma'am. You must come to the microphone.
So I heard you were talking about being a bellhop and a janitor, but when did astrophysics, is that what you call it? When did that become like your main thing? Like how did that happen?
Okay, how that happened. So basically, when I was growing up, I never lived in the same state 2 years in a row. My parents divorced when I was very young, and every year we moved to a different neighborhood in a different state. So first grade, I was in Houston. Second grade, I was in LA. Third grade, I was in New Orleans. Fourth grade, Mississippi. Fifth grade, back in New Orleans. Sixth grade, I went to 4 schools in 3 different states. Seventh grade, Houston. And every community that I lived in, we lived in like the worst community. We lived in the hood, right? And so, you know, you're the new guy in the bad neighborhood. What do you got to do? You got to fight, right? So, you know, life was a little hard on a brother in those days. And we had a set of encyclopedias in our house. We had the World Book encyclopedias. And my mom liked to read, and so I liked to read. And by the time I was 10, I literally read those World Book encyclopedias from A to Z. And in that process, I discovered Albert Einstein and special relativity. And right, and what relativity says is that, you know, if your speed determines reality, right? So let me give you an example. Did you all know that at this very moment, we're all moving at the speed of light? You knew that? In which direction? Left? No, through time, right? So here's how that works. Your speed through space squared plus your speed through time squared is equal to the speed of light squared. And since we're all at rest through space relative to each other, that means together we're all moving through time at the speed of light. But if one of us was to take off moving really fast through space, we must necessarily move more slowly through time, right? And that's what the movie, the Planet of the Apes is based on, right? These, you know, these astronauts leave Earth going really fast. When they come back to Earth, it's been 10 years from them, but on Earth, you know, hundreds of years have passed. So that's real. That's real phenomena. That's what really happens in the universe. Not only that, the lengths of things change when they go faster. And so I thought this was just the most amazing thing ever, right? And so I studied as much Albert Einstein, as much relativity as I could, and I was also attracted to the really weird stuff. You know, I like ghosts, I like the Loch Ness Monster. Is anybody else into the weird stuff? Is it just me? Yeah, right? So if you're into the weird stuff, you're halfway to being a scientist yourself. Now you just gotta go to college and don't be scared, and don't quit. Any more? Come on. We've had 2 brave women, yes, and another 3rd brave. You know, I've never been to a school where all the first questions were answered by the women. Chicago, yeah.
Okay. Hi, how's it going?
Hi, it's hot up here. I don't know how it is down there.
It's cool. We chilling.
Y'all chilling? All
Yeah, we
right.
chilling. Okay, so you're an astrophysicist.
Yes,
so
ma'am.
assume you study about gravity.
Yeah, a little bit.
So
It's hard though.
can
Gravity's
you
tough.
tell us what exactly is gravity? Is it just a force that exists or all
Yeah.
that? And then tell us more about what you study as an astrophysicist.
Okay, yeah, great. So she asked me to talk about gravity and what exactly is gravity, and to talk about what I do as an astrophysicist. So I like to ask my physics students in college what exists. At the most fundamental, what exists, right? And we eventually get to this list, right? Mass, energy, space, time, and these things we call fields, right? We know about electric fields, we know about magnetic fields, we know about gravitational fields. And fields are really weird, right? Fields are the things that we really don't have a good grasp on what they are fundamentally, right? I can say some crazy words like, you know, oh, the electric field is due to virtual photons, right? But it's kind of nebulous. Gravity is the least understood among all those fields. And so it turns out that space and time, what we call space-time, seems to be something. And that something seems to alter its shape based on the density of mass and energy in space-time, right? So the way gravity works, the simple explanation is, like even you, right now you're bending space-time. Everything that has mass bends space-time around it. And so the curvature of space-time is based on the amount of stuff in space-time, and the motion of everything through space-time depends on the curvature of space-time. So if you look at the motion of the planets around the sun, right? It's the motion of space that keeps them locked in their orbits, and it's the curvature of time that keeps them moving, right? So that doesn't say a whole lot, right? It's really weird. So you just gotta read for years and years and years. to figure it out. Now, what do I do? So I have a research group that's working on 3 different projects. One project is, if you look at the surface of the sun, there are these 2 big problems. Have you guys ever seen the pictures of the corona with all these plasma loops and movies and all the explosions with flares? Have you seen that? Yeah, so it turns out that in my graduate school work, I was on the team that pioneered that technology. We did that for the first time, made those sorts of images, right? It was led by a guy named Art Walker. And so what we want to do, imagine that this surface right here is 6,000 degrees, but yet the air above it is millions of degrees, right? That doesn't make sense, right? As you move away from a source of heat, it should get cooler, but that's not what happens on the sun. The surface of the sun is about 6,000 degrees, but there's this atmosphere above it that's millions of degrees. That's always there. How does that work? And that's called the coronal heating problem. The other side of that problem, have you guys heard of the solar wind? You know, comets, their tail always point away from the sun because of the solar wind. Well, why is there a solar wind? Gravity at the surface of the Earth is 30 times greater than gravity at the surface of the sun is 30 times stronger than gravity at the surface of Earth. But yet the sun's atmosphere just runs away from the sun. It flows away. Why is it doing that, right? So that's also a not well understood problem. So that's one of the things that we do. We try to understand how the solar wind is formed and also how this gas is heated. And the way we understand that is by looking at the interaction of the magnetic fields and the plasma. The second thing we do is we're trying to understand how our galaxy formed and how the universe formed, right? So our galaxy has a disk where there's a lot of stars and gas. We're in the disk of the galaxy. And then there's this huge spherical distribution known as the halo. And in the halo, there's not much stuff. And so the gravity there is not as strong. And so any structures that formed the galaxy by coming in, they will remain intact in the halo. And so we're basically doing archaeology of the galactic halo. And then the third thing that we're doing is we've invented a new technique for in-space propulsion. So have you guys heard of Mae Jemison the Astronaut? Yeah, so I'm working with Mae Jemison and several others, and we're working on what's called the 100-year Starship project. So our government has decided that in 100 years, we are going to begin building a starship to send humans to another star system, to other planets, right? And so in my research group, my graduate student Dave Chesney has envisioned, and we've worked out the physics of a new in-space propulsion technique. So we're trying to send humans to the next star. So that's what we're doing. Next question. Yes, sir. Come on up. Finally, a guy. So you couldn't let the guys go out like that. So you had to represent.
All right. In here. Is there a possibility that there's like any life species in space?
All right. The question is there a possibility of there being any life elsewhere than Earth? The way I see it, you know, when we look around the universe, we see that everywhere is pretty much the same. It's the same physics, the same matter, the same chemical compositions. So in my mind, the only evidence that I need that there's there's life elsewhere is that there's life here, right? And so we don't know that. It's just like finding planets elsewhere. We used to ask ourselves, are there planets around other stars? But we knew how stars formed, and we knew that planets were formed from the stuff that was left over from the birth of stars, right? And so that means that pretty much every star should have planets. But we didn't know how to find planets around other stars. So starting about 20 years ago, we were able for the first time to find planets around other stars. And then we got really good at it. And guess what? Everywhere we look, there's planets around every star. There's more planets in our galaxy than there are stars. And there's hundreds of billions of stars in our galaxy. Right? So what's the chance that we're the only life in our galaxy? Right? It's pretty small if you ask me. So I think that's the answer is more than likely. We haven't observed it, so we don't know that there's life elsewhere, but I think in all probability, life is everywhere. But again, if we look at life on Earth, for the first 3.8 billion years of life on Earth, it was all single-cell life. It's only been in the last 800 million years or so that we've had multicellular life. And only in the last couple 100,000 years that we've had intelligent life. So chances are life is everywhere, but it's single-celled everywhere. And only in a few places is it multicellular, and in even fewer places does intelligence arise, in all likelihood. More questions? Yes, ma'am. Oh yeah, see, a few people start, then it just...
I want to become a scientist when I grow up.
Yes.
I've been knowing this since I was in kindergarten. Do you know anywhere to start? Because I'm looking into different types of, and I'm just trying to know what to start first, just as a plan.
Well, the thing to do first is tell others that you want to do it, right? So the way this works is, you ever notice that almost all scientists have white hair? Yeah, I actually have white hair, but I color it, right? I'm 84 years old, but I'm just in really good shape if you drink water. So here's the deal. If scientists become aware of a young person that's interested in science, they will do everything they can to help you become a scientist. Because in order for our country, and here's the thing that a lot of people don't realize, if you go to graduate school to be a scientist, like a physicist or a chemist or something like that, you don't pay to go, they pay you to go. Right? Your tuition is paid and you receive a salary if you plan to get a graduate degree in a science. Not engineering, you typically have to pay for that. But if you're going to go into a pure science, because it's necessary for the health of our country. And the reason why that works is because it takes a long time to become really good at science. That's why all scientists have white hair. And then when you get really good, it's time to die. So you got to have a constant flux of new humans into the system, right? And so the next thing is, I'll tell you this, outside of sports and entertainment, I don't know a single person who wanted to become something and actually tried to do it and worked at it that did not achieve it, right? And so all you got to do is start the process, let everybody know that's what you want to do, and keep at it and you will become it. One of my favorite phrases is, if you think you can do something, you're probably right. If you think you can't do something, you're definitely right, right? So if you try, chances are you'll accomplish it. But if you don't try, you've decided already. Next question. I saw a lady here. Yes, ma'am. Come on up. Oh, and by the way, if anybody wants to have a rap battle with me, we can do that too. Sorry.
Okay.
Yes,
Okay.
ma'am.
So I've heard, I'm not sure if it's a theory, but I was kind of watching a movie, and it said that the closer that you get to the sun and the more mass that you have, the faster you burn.
Oh, no, that's just made up.
Okay.
Yeah, but here's something cool about the sun. You know the sun is growing a little bit bigger every day, and then eventually it will engulf the earth. So the whole idea that humans have to leave Earth, right? We're either gonna do it or go extinct, right? So, there's the dangers from asteroids and comets, and then there's the cutoff date of sun swellingness. Though the sun will never explode, which a lot of people think is gonna happen. Next question. Come on up. Yes, sir. A man in uniform. I used to be in uniform. I was in the Navy. They taught me algebra, actually.
I think I might take you up on your rap battle, but
All right.
not right now.
Oh, okay.
I saw you were on that show, the Evacuate Earth.
Yes.
What is your theory on how the world will end?
Oh, that's a really good question, right? So there are, the question is how the world will end and how will human life get wiped out. So there's a lot of things that could happen, right? So for example, if there's a nearby supernova, right? There's a star named Eta Carina, which you can't see from the northern hemisphere, but you can see from the southern hemisphere. That thing can blow up any day, right? And that could impact Earth, especially like a lot of exploding stars, when they explode, they have a jet of material that flies out that includes gamma rays, right? If that's pointed at Earth, that could be very bad, right? The other thing that happens is that if you look at the night sky, it looks like individual stars, but half the stars that you see are actually double stars that are orbiting each other, right? And so as stars, they're called binary stars. And so stars, they're born, they evolve, and they die. So there's probably dead binary pairs out there, like little white dwarfs, right? And that's what the sun is going to become, a white dwarf star about the size of the Earth. And it won't be very bright. So you can't see white dwarfs that are far away, right? So as these stars orbit each other, they get closer and closer and closer together because they emit gravitational radiation. right? And so they lose energy and they get closer and closer and eventually they collide. And those are incredibly powerful explosions. So if something like that happens nearby, that could get us, right? We know that comets and asteroids hit Earth periodically and it's gonna happen again, right? And so that could get us. That's probably the next thing that's gonna happen. And then there is the fact that the sun is expanding every day. And then there's the stuff that humans do. So it turns out that after the show Evacuate Earth, I did a series called How to Survive the End of the World. And we have all these scenarios. Look it up, Google it or something, right? Or YouTube it. And so we have all these different scenarios of how the world could end, but then we tell you how to survive, right? How to be one of the lucky ones. But that stuff is fiction, though, I gotta say. It's not very factual. But it's interesting to think about, right? Yes, come on over here, somebody from over there. From this point forward, it's $100 per question. Take up a, all right.
Earlier you said how everything moves at the speed of light, some through time, some through space.
Yes.
Why does light put all of its motion into space, and how does it travel forward in time if all of its motion is in space?
Great question. It doesn't travel forward through time. Light is frozen in time. And the other thing is that in our universe, if you have mass, you can never move at the speed of light through space. Notice I say it through space. There's a caveat. But if you are massless, you must move at the speed of light. So because light is massless, it must move at the speed of light. So it turns out that this Mexican scientist, Alcubierre, he came up with what's called a warp bubble. And so we have an idea for moving at up to 10 times the speed of light by expanding space behind you and contracting space in front of you, right? And so that's called the Alcubierre warp bubble. Now, there's another thing. Have you heard of quantum entanglement? Yes. So Albert Einstein was hating on quantum mechanics, and he sought to see if quantum mechanics predicts anything that we know can't be true. And he found that if you prepare two elementary particles, say two electrons, they have certain properties like what we call spin, take for example. And these properties, when they're created, they have to be complementary. So if one is spin up, the other must be spin down. And so Albert Einstein found that if you take these two particles and separate them, no matter how far apart they are, if you measure the state of one particle, the other one must automatically be in the other state. And so this one is allowed to change state. So that means that they must communicate with each other somehow, and it must happen instantly. So he predicted this decades and decades ago, and we were only able to measure the effect very recently, and guess what? It happens, right? So this completely blows our mind in terms of what we know about space and time. Because in order for two things to interact, something must traverse the space between us, and that takes time. The force of gravity moves at the speed of light, right? So we don't understand space and time fundamentally, and we know we need to improve on that, so maybe that's what you can win your Nobel Prize doing it. Great t-shirt, by the way. That's the theory of electromagnetism on your shirt. You knew that? Yeah. Awesome. Great question. I noticed everybody applauded for you when you came up, so you must be the smart kid. Yes, ma'am. Yes, you with your hand like way high and... Dun, 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 dun.
Do you ever think that time travel will be possible?
Do I think time travel will be possible? We're doing it right now. We're traveling into the future. Well, listen, it's theoretically possible to travel into the past. You want to know how to do it? Okay, so if you have a wormhole, which is based on a black hole, right? You go into this wormhole, you pop out somewhere in the universe, right? So if you move the end of the wormhole where you go in around at near the speed of light, then you can potentially pop out the other end of the wormhole before you enter the first wormhole, right? Now, in order to Google Einstein-Rosen bridge, it's hard to hold a wormhole open, so it'll probably never happen. Yes, sir. Come on down. You're the next contestant on The Science is Right. Yes.
going back to the whole speed of light stuff, Professor Stephen Hawking, I believe, at one point said that if one was to travel at the speed of light for a week, then when they emerged, they would be 100 years or so in the future.
Yeah. I don't know the exact, not at the speed of light. I mean, it's a very simple calculation, right? So take the square root of 1 minus the speed you're moving squared divided by the speed of light squared, right? Take the reciprocal of that, and you get this factor, it's called gamma, right? And so you want gamma, and you multiply that by the time measured in the rest frame. So you want gamma to equal 100. So figure out the value V so that 1 minus gamma squared over c squared equals 100. And it's really simple, yeah.
And also, the big bang,
yes.
When the outward force from the explosion...
There was no
runs
explosion.
Out, well, the rapid expansion of the universe, when the outward force dies down, will it start retracting?
No, that's another very good question. It turns out it's the exact opposite. Over the course, so everybody wanted to know at what rate the expansion of the universe was slowing down, because it should be slowing down, because galaxies are made of matter, they're gravitationally attracted to each other, so it's just like if I take a rock and I throw it up, right, once it leaves my hand, it's gonna slow down, right? But imagine I take a rock and I throw it straight up in the air, and at first it's slowing down, but then it starts to speed up. Weird, right? That's exactly what the universe has done. And that was discovered in 1998. It won the Nobel Prize in 2011, and that was the discovery of dark energy. So the expansion of the universe is in fact accelerating. Yes, ma'am.
Hi.
Hi.
Can you tell me the most mind-blowing thing you know?
The most mind-blowing thing I know. I got a PhD in physics. All right, I'll tell you about something you never heard of. Have you guys heard of superfluids? No, okay, so superfluids happen when you take some materials and you cool them down to almost absolute zero, right? Now, say for example, I have a bucket of water here, and I take a cup, a tall cup, right? And I put a hole in the bottom of the cup, and then I press it almost under the water completely, but not. I leave some of it sticking up out of the water. What happens? Exactly. He says it'll eventually smooth out. What he means is water is going to enter that hole at the bottom of the cup, and it's going to fill that cup until the level of the water on the inside of the cup is exactly the same as the level of the water on the outside of the cup. Now let's say I have a bucket of superfluid helium, and I take a cup, I don't put a hole in it, and I press it down into the water so half the cup is sticking out. Guess what will happen? The superfluid will climb up the side of the cup and down into the cup until the levels are the same inside and out. Yeah, it's really weird stuff. If I take a little cup of superfluid and hold it over a bucket of superfluid, the little cup of superfluid will climb up the side of the inside of the cup, down the outside, and then drip down into the bucket until the cup is empty. No, liquid nitrogen is not a superfluid, it's too hot. You gotta be at millikelvin temperatures, right? That's thousandths of a degree above absolute zero. Yeah. Was superfluids weird enough for you? How about this? Did you know that people have actually created transporter beams? Did you know that people have actually created invisibility cloaks? Did you know that people have actually created life in a test tube? You knew that? Yes. Ma'am, you had a question? Come on down. Yeah, it's her.
So you know how people say when you use a shell and you put it in your ear, you could hear your blood vessels? Do you know why your blood vessels, the hearing of it goes through and then back in your ear?
Yeah. Well, I'm gonna ask you a question. Do you know what the most important thing to recognize is in order for moving forward scientifically? There's two things. One is, I always tell people that I ended up in an argument with. I was like, listen, if we're arguing, you're obviously wrong. The reason why is because I know when I don't know, and so I don't argue something if I don't know. I don't even say it. I have no idea about the shell in the cup. I don't know, right? And so that's one of the most important things for being a good scientist is knowing when you don't know. And you know what? There's a lot of things we know that aren't actually true. And there's a famous quote in science where someone said, what stops us from moving forward is not what you don't know, it's what you know that ain't so. Yes, ma'am, come on down. Instead of going down the aisle, jump over the guys in front of you. All right, come on. Yes.
How often black holes happen?
Oh, black holes are happening all the time. If you look at, there's black holes that form from dying massive stars, right? So if a star is more massive than say 5 or 6 times the mass of the sun, when it dies, it'll form a black hole. So those black holes are incredibly common. If you look at galaxies, just about every galaxy has a supermassive black hole in its center. These black holes have masses that are millions to billions of times the mass of the sun. In the visible universe, there are hundreds of billions of galaxies, and each one has a supermassive black hole in its center. And there's even more dwarf galaxies, and they have black holes in their center. So if you look at we're at billions, hundreds of billions of black holes in the universe. So black holes are incredibly common. Yes, come on down since you pulled up a two-hander. Woohoo, yeah. Represent chemistry. All right.
Hi.
Hi.
Okay, so do you believe that the universe is infinite, or like what is, I don't know.
Okay, let's start with the basis of your question. You asked me, do I believe? What does that word mean?
Think, do you?
That's like accepting something that's true without knowing that it's true, right? I can know something or I can believe something, right? When it comes to the universe, I don't do the second one, right? We think in terms of probabilities, So what was the question?
Is the universe infinite then?
What's the likelihood that the universe is infinite? Tell me where infinity exists in nature.
Pardon?
Where does infinity exist in nature?
I'm not sure.
Pretty much nowhere, right? Yeah. So, there is one place where infinity seems to exist, but infinity is not something that really occurs in nature, right? So we don't know if space is infinite, but because of our ideas about the very, very earliest moments of the universe, what we call inflation, what seems to be most likely is that the entire observable universe is like this big, whereas the universe is like that big. So we think that what we can possibly see is only a very tiny fraction, but we don't know if it's infinite or not. But, I'm not that cool with infinity.
Thank you.
No, time had a beginning. There's what is famously known as Olber's paradox. Look it up, Olbers. And so if time went infinitely back far into the distant past, then the night sky would not be dark. Yes, next question. Yes, come on over. Why does everybody get an applause when they come from that side of the room? All right.
What do you think of wormholes?
They're kind of squiggly and circular.
Yeah, okay.
Yeah.
I have another question.
Well, if you look at wormholes in detail, they can't exist for very long.
Okay.
Yeah.
So,
What's the other question?
What's 9 plus 10?
Wait a minute. Let me get my calculator. All right, let's see. Take the integral. All right, third derivative divided by the. That's too hard. I can't figure that one out. Yes, come on up. You two in the back. 2 people at a time. 2 at a time. You too, young lady. Yeah, you with your hand up on the end of the row. Yes, you. Yeah. Yes, her. Yeah. 2 of you. Come on. Yeah, come on. Yeah. Come on, you too, sir. Both come back. No. Keep coming. No, those 2. You sit back down, Mr. 10 plus 9. I almost jumped down there and you two, we got 2 microphones. Come on. Yes.
Okay, So, why, like, is it that when you suck helium, your voice gets, like, really high?
When you suck?
No, like, when you, like inhale helium.
Oh, it's because of the, I think it's a low mass and density of helium. I really don't know, but.
Oh, okay.
Yeah. Yes.
So, when you were younger, did you ever think that you would be where you are today?
No. Not even close. Yeah, I had no idea. The day I graduated high school, I had no idea. Yeah, you, sir, come on over. In fact, I joined the Navy out of high school. I thought I was going to be a submarine captain. Yes. Yeah!
So, like, what happens when, like, objects go through a black hole?
No one knows. They die if they're living. That's spaghettification. Yes, all right, let's get somebody from back here. Yes, come on down. Yes. You're the next contestant on The Science is Right. Let me guess, you're not in the 7th grade.
It's true, I'm not.
All right.
Okay, hello.
Hi.
Hey, is teleportation possible?
It is happening already. People are doing teleportation.
Can I teleport?
No. Yes,
Why?
at the quantum mechanical level, you're too macroscopic.
Sure.
You should like make that your Twitter. I'm too macroscopic to teleport today.
Can humans teleport?
Not today, right? So people have, there was an announcement just last week of someone made a teleporter that could both, no, that was a tractor beam, I'm sorry. But quantum teleportation is happening right now. And typically with these things, doing it from the, at the small scale is, doing it the first time is difficult, but after that, it gets, it's easier to do. But teleportation is one of those things that probably will never be easy to do. Yes, come on down. 2 more, come on, someone else come. Who else on this side of the room? Let's get another person too. Yeah, come on, you two.
Do you think there's a cure for Ebola?
Is there a cure for Ebola? Well, you know what? Remember when that first American had Ebola and they went to the CDC in Atlanta and they were cured? You remember that? Yeah, they had the secret cure. So one of the things that you get to learn about as a scientist, you talk to other scientists, you serve on panels for corporations and the military and stuff like this. And what you learn is that there's a lot of secret stuff. That's pretty awesome, yes.
How does an invisible cloak work?
How does an invisible cloak work? It's pretty simple, right? You measure a light ray coming in on one side, and then you project the exact same light ray at the exact same intensity on the other side. And so essentially you're just like, accepting, and it's like the person isn't there. And you can even make one with mirrors. All right, young man in the red jacket, looking like Michael Jackson, and the next one behind you. Yeah. All right.
Hi.
Hi.
Is cloning possible, like cloning of people and animals?
Oh yeah, yeah, cloning has been going on for a very long time. Yeah, in fact, I'm a clone. What? No, I'm just joking. But no, yeah, they've been cloning. The first large animal to be cloned was a sheep. It was a very famous sheep. Yeah, we're cloning, man. Yeah.
Cool.
Yeah, and I'm gonna have a clone army someday, and we're gonna take over the world, yes.
What are your thoughts on space junk, like orbiting the Earth?
Oh yeah, space junk is a huge problem. In America, we now have the law that if you put something in space, you must deorbit it, right? And so, for example, the Hubble Space Telescope, the plan was that we'd send the shuttle up and capture it in the shuttle and then bring it back down to Earth and stick it in the Smithsonian. But after that second shuttle disaster, it was determined, okay, that's too dangerous. We're not gonna risk astronaut lives. And so the next thing that we did is we hired a company to go and put a rocket on it so that we could deorbit it into the ocean in a controlled manner. But if you look up online a map of all the space junk that's surrounding the Earth, it is a lot. And when you're out in space, a tiny little thing moving at 26,000 miles per hour will really jack you up, right? Did you see that movie Gravity? Yeah, and that's the thing with space junk. Space junk begets more space junk. So it's really a big problem. So we need to figure it out. Come on down, 2 people. 2 people, first 2 people. And you too, you come on down, sir, yeah. Two at this microphone and 2 at that microphone. Is this the rap battle? Yes, sir. Yes. I think they both work. Speak into it, see what happens. Oh. Hi.
My question would be, what would happen if our galaxy would collide with another one? What would the aftermath be?
Oh, see, our galaxy is colliding with another one. Right now, the Sagittarius dwarf galaxy is colliding with the center of our galaxy, and us and the Andromeda galaxy, which is much larger than us, is headed right at us, right? So in a few billions of years, they're gonna collide. But here's the thing. Do you know how far apart stars are? So the average star is about 2 light seconds across. On average, stars are like 3 light years apart, right? So you know how many seconds there are in a year? Anybody? It's about 30 million. So stars are about 30 million times their own size apart from each other. So let's put that in human terms. Let's say I'm 2 meters tall, and the next human was 30 million times my size away from me. They will be 60 million kilometers away. That would be 60,000 kilometers, so they wouldn't even be on Earth. So when galaxies collide, the stars basically don't collide, right? It's these giant clouds of gas and dust that exist in the galaxies that collide, and what that creates is starburst, lots of star formation. So the galaxy is gonna get really bright. Yes, great question. Yeah. Yes, sir.
In my social studies class, we were talking about Mars about a week ago.
Yeah.
And I had a question like, do you believe there's life in Mars?
Well, we haven't found any life on Mars, but it looks like, you know, one of the necessary elements for life is water. And it looks like there was fluid flowing on the surface of Mars. That's been pretty conclusively shown, and there is water on Mars. And so the question is, you know, can we find fossils? There was one Martian meteorite that appeared to be contained fossils, but it wasn't conclusive. So we don't know. I don't know, right? The best places, I think, for life in our solar system are Titan, a moon of Saturn, Europa, and Enceladus, 2 other moons. And these are places that we know have lots of liquid. And Enceladus and Europa is liquid water, so.
Okay, thank you very much.
You're welcome. Yes.
Do you think Star Wars has anything to do with reality?
Yes. It's a lot of politics in Star Wars. It's a lot of politics in reality. And that's why I'm building a clone army. You should too.
Hi.
And work for me. Yes.
What happens when light goes into a black hole?
That's a really good question. So nobody knows what happens when anything goes past the event horizon of a black hole. It's all speculative because we can't observe. And if you don't observe it to be true, you know, can you consider it to be truth? But the thing about a black hole is that there's a region around the black hole where gravity is so strong that light actually orbits the black hole. And you get what's called the, what is that called? It's something a sphere. So yeah, black holes are really cool, and actually a black hole can drag space-time around it as it orbits. So if you get near a black hole, you should Google what it looks like to be near a black hole. Things are really cool. Awesome, you came up without me even having to say, come on down.
Has a human ever been cloned before?
I don't know if there's a human clone, but like I said, the one thing I do know is there's a lot of secret stuff happening in the world, and some of the best cloning work has been done in Korea, so I wouldn't put it past North Korea to have cloned a human.
So why haven't scientists
Done it?
yeah, so why aren't clones
Ethics.
just a normal thing?
Ethics. It just seems unethical, right? It doesn't seem to be the right thing to do. And so, you know, that's one of the, you know, in science we have ethical dilemmas, right? So the scientists that created the nuclear bomb, right, you know, they had huge ethical problems. So now life sciences and genetics, it has just exploded since the 1990s. And so a lot of things are going to be possible. And, you know, we have to decide, should we or should we not do it based on moral and ethical grounds, right? And that changes with time. So, you know, it may happen in the future. Yes. One more. One more. How about 4 more?
Did you
I'll be fast.
did you study only Einstein, or did you study other people?
Oh no, I have a lot of scientists, like even ancient scientists like you never heard of, like Ibn al-Haytham, the first modern scientist, Aryabhata, somebody from the ancient Gupta dynasty, Isaac Newton, he was a big jerk but an amazing scientist, Fritz Zwicky, right? Look up that guy, 20th century, great scientist. Yeah, so there's I love the history of science and humans. Yes, ma'am.
So you said that the universe can't be infinite?
No, I didn't say it can't be infinite.
But-
I think it's unlikely because
Yeah.
infinity doesn't
But then
really exist. Yeah.
Wouldn't that imply that the Big Bang would be a spontaneous event?
Well, there's a lot of spontaneous events that happen, right? They're the ones that minimize energy. And so, but here is a secret that not a lot of non-physicists know. The Big Bang requires a space and energy to exist prior to it. So we don't necessarily think of the Big Bang as being the beginning of everything, but there could be other universes. And in fact, that's, why would there only be one universe and it's the one that we're in, right?
If there's certain causes to the Big Bang for it to be able to happen, wouldn't that mean that would just go back forever? Because
Not necessarily. It doesn't have to. But there are some people that think that, it is a spontaneous event due to quantum fluctuations in a certain state of the early universe, and that you can have many parallel universes that are born. But we don't know, right? I mean, you're trying to make a logical inference that if it happened, it had to have happened before, right? And that isn't necessarily so. That doesn't logically follow that it's necessarily so that if it's possible for something to happen, but we don't know.
Yeah, because if you look at quantum fluctuations, they seem to be random and spontaneous because you can't predict where the next particle is going to be going. But then if you look at material events, can't you usually decipher some sort of cause and effect? Is that why?
No, it doesn't. Okay, so the way it works with quantum mechanics is that it's not random, right? The difference between classical physics and quantum physics. In classical physics, if you have the proper initial conditions, you can use the laws of physics to predict the necessary previous and the necessary following, right? In quantum mechanics, if you have a boundary condition, an initial condition, you predict with the exact same certainty the ensemble of possibilities, the spectrum of possibilities. It's not like anything can happen, right? And each of these spectrum of possibilities has a probability associated with it. So the most probable ones occur most often, right? So it's not that it's completely random. It's not, right? Quantum mechanics, quantum phenomena is not, like rolling the dice. It's not like that. There are very precise probabilities that you predict. And when you make measurements, that's what it is. Let's get the other questions in, but hit me on Twitter or something.
One more question.
Yeah.
So you were talking about fields when you explained gravity. Could
Yeah.
you explain the 0-point field?
The 0-point field is again, like for example, what is the nature of space-time, right? So we know that we have energy in space-time, right? So this fundamental energy that exists in space-time, we call the 0-point field, right? And we make it like this quantum foam that exists.
Okay.
It's an intrinsic property. But again, we know because of dark energy that we don't know everything, because when we use that to predict the value of dark energy, we're off by 120 orders of magnitude. Yes.
So I have a question about, because you were just recently talking about black holes.
Yes.
And so this question came to my mind that if you said that there's nothing that we can think of that's infinite, then
Right.
how would you explain where do things go in a black hole?
Right, exactly. And that's a debate among people that study black hole. Is it infinite density? Is there a singularity? And people, find it distasteful that there would be an infinite density and singularity. And so people have come up with many different ideas for what happens inside a black hole. A couple of good friends of mine, they modeled and they got a lot of press. They were looking at Bose-Einstein condensates, right? And if you look at a wave moving toward a Bose-Einstein condensate, it looks exactly like light moving toward the event horizon of a black hole. And so they said maybe a black hole is a phase change of space-time, and our complete description of what happens inside the event horizon is completely wrong, right? And so because we can't make measurements of what's happening inside of it, we're stuck. All right, next one, because we're running out of time. You two gentlemen, I'm sorry, we don't have enough time. Yes.
So my question was, can we send anything on a light beam?
Can we send anything on a light beam? We do. They're called fiber optics, and we send information on light beams all day, every day. Yes. Last question, but not the least.
There was an experiment conducted where it was they shot photons through two holes.
Yeah.
And it's almost like the results were different. They shot one photon, there was like, when they looked at it, there was only like one bar, and then when
Yeah.
they looked at it again, there was like scattered. How does
Right.
that happen?
Yeah, it's what's called, and they do the exact same thing with the electrons. It's called Young's double slit experiment, and what that shows is that all elementary particles, they travel like waves, but they share energy and momentum like individual particles, and it turns out that the actual act of making an observation changes the result.
Is that like also the theory of like, it was like radioactive degeneration? Like if you put something in a box with a radioactive element, you can't tell if it's like.
You talking about Schrodinger's cat, right? The living or dead? Yeah, that just has to do with the probability of outcomes, right? And so the point is that until you make a macroscopic observation, you don't know what state it's in, right? But it chooses a state if you make an observation. So if I have like a cat in a box with poison, if I don't make an observation, then the cat is both half alive and half dead. And then when I make an observation, then it chooses to be alive or dead, right? So that was some scientists hating on quantum mechanics. But we're out of time, so thank you guys for having me out. And I hope you all follow all your dreams without hesitation. And hit me on Twitter @Hakeem Oluseyi.